Alright, as you have learned from the previous chapter, which is the differentiation. So now we are going into the application of differentiation. And the first subtopic is the related rates or rates of change. Actually, the idea is to find the rate of change of one quantity in terms of another quantity whose rate of change are known. Let's go to the example. So look at example here. The width of a rectangle increases at a rate of 2 cm per second. The length is 5 times its width. Find the rate at which the area is increasing when its width is 5 cm. So as you can see here, we want to find the rate of the area. So that means when we mention rate, we know that it is over time. So that means the rate of area, it is dA over dt. So this is what we want to find. And it is given when the width is 5 cm. So to make this question more understandable, so you have to draw it. So let's say the width of a rectangle. Right, this is a rectangle. The length is 5 times its width. So this is, let's say we have the width is x and the length is 5x. And mention here 2 cm per second. Cm is its length, so dx, since our length is in terms of x, over dt is equals to 2. So we want to find the rate of the area. So actually we can use two methods, which is the first one is the chain rule and the second one is by using implicit. So first, I will show you how to use chain rule. To use chain rule, so we know that to find dA dt is equals to, I just draw a line, okay. So dA dt, so we know that the first is dA and over dt. So we want to find what is that we need to cancel here. So we know that we have the length, dx. So you can write down dx here over dx. So that when we cancel dx and we will get back dA over dt. In this info, we should find what is our dA dx. dA over dx is equals to, so this is what we want to find. So we know that the area for this area is equals to 5x times x, and that is equals to 5x squared. So this is our A. So when we differentiate this, we will get 10x. This is our dA dx. Right, let me repeat. This is our A, area. A is area. So area of rectangle, length times width. So 5x times x is equals to 5x squared. When you differentiate to get dA dx, so you differentiate 5x squared, you will get 10x. Okay, so we know that our dA dx. So we want to find dA dt. dA dt is equals to dA dx 10x times dx dt. dx dt is given here 2 times 2 is equals to 20x. Alright, and the question asks, find the rate of the area is increasing when its width is 5 cm. So this means when x is equals to 5. So we just substitute dA dt when x is equals to 5 is equals to 20 times 5, since our x here is 5. So we will get 100. So what is the unit? Since area is centimeter squared over time, so per second. This is the method by using chain rule. Alright, now I would like to show you how to find the rates of the area by using implicit. Okay, from the question here, we know that the area is 5x squared. And then to find by using implicit, so we have to differentiate both sides from the left side and the right side with respect to t. So when we differentiate a with respect to t, and we will get dA over dt is equals to And also when we differentiate 5x squared with respect to t, so we will get 10x multiplied with dx dt. I hope you still remember how to differentiate implicit. So we have 10x times dx dt. And the question asks, find the rate of error when x is equals to 5. So we just substitute dx dt when x equals to 5. 10 times 5 times dx dt, we know that this is our dx dt is 2. So we will get 100, and the unit is centimeter squared per second. So I hope from this example you know how to find the rate by using implicit and chain rule.